So continuing the story, the surface currents are driven by winds, and we said they are mostly horizontal, very little vertical structure in the wind-driven currents, but whatever structures there are, they are important. Deep currents, on the other hand, we said have vertical structure and horizontal structures, and they are also measured often very indirectly because they move much slower than the surface currents. I said most ocean currents are at centimeters per second, so just a few kilometers per day, whereas the deep currents are just a few kilometers per year. That is really slow, very difficult to measure them directly, but there are what are called chemical tracers. So during the 50s, for example, there was a lot of nuclear tests carried out in the atmosphere because we didn't know at the time how dangerous radiation was. So some chemical radioactive material like tritium got released, which obviously get constantly taken up by the ocean, and they are inert, and they have a flow pattern in the deep ocean. Knowing the concentration at the surface when it would have entered and the location of the tritium now, you can kind of trace the concentration pathway and estimate the deep currents using that method. Chlorofluorocarbons, which are CFCs that refrigeration was using very heavily till the ozone hole was discovered and the Montreal Protocol was signed, and we realized it's causing chlorofluorocarbons are leaking chlorine and disintegrating or disassociating ozone, which is not a good thing. So CFCs also have entered the ocean and continue to act as chemical tracers. So knowing the source, the sink, when they enter the ocean, where they are now, what concentration they are in, and so on, you can estimate deep currents. So you can also use characteristic temperature and salinity to derive the dynamic topography and pressure gradients and currents and so on, which are again indirect methods of deriving currents. Deep currents nowadays are also being measured by something incredibly useful called the Argo Float. Image is shown on the right here next to a ship. Basically, it's a cylinder with an antenna at the top that's sticking out here of the water, and this has a sac which changes its buoyancy. So you can make it sink to 1,000 meters or 2,000 meters, and it'll just drift there for about 10 days. And then after 10 days, it comes slowly up to the surface, measuring temperature, salinity, and sometimes, of course, pressure, and sometimes other things like oxygen. Comes to the surface, sends the data to the satellite, and then goes back down. Why does it stay below the surface? Basically because anything you put in the ocean has a problem. It's called biofouling. Anything you put in the ocean, like a jetty or a broken ship that's floating around or a little piece of rock, biology begins to grow on it. Okay? And then fish congregate around them and so on, and moored arrays end up becoming what are called FADs, or fish aggregating devices, which means fishermen will come along and they will anchor their boats to this instrument and fish around it and destroy the instruments and so on and so forth. So Argo has this incredible design where it sinks to the bottom where there is no light, no biology, very little biology, so biofouling is minimized, and it comes up whenever you order it to come up, measures the profiles along the way, comes to the surface, beams the data, and goes back down. The top plot here is showing that in 2012 there were almost 3,500 floats around the world. Looks like a big coverage of the world ocean because the dots are very big, but if you put the real size of the dot, it will not be visible at all. Anyway, it's an international program. Even India is involved, Australia, US, Europe, everybody is involved, China, Japan. and they all put certain number of Argo floats which all follow the same protocol of measuring and beaming data and so on in their region or in a region where they have some interest, international waters. Remember, a lot of these international waters, somebody has to pay for the Argo and put it there. It has a limited battery life, so they have to be recovered, battery has to be replaced, and so on and so forth. Nonetheless, Argo floats have now become the workhorses. They've been collecting incredible amount of data since about 2004. The coverage continues to increase, and the number of things they measure, in addition to temperature and salinity and pressure, also begins to increase with light and oxygen and nutrients and so on and so forth. There are design issues. As you add more instruments, you will need more battery and so on and so forth. So Argo, remember, go on the web, look for them. There are very nice animations of Argo and so on. Okay, beautiful concept that's now functional, fully functional, and producing very good data for oceanographers for monitoring not only ocean currents but also ocean heat content, which is very important for global warming, right?